Welcome back everyone. So in the last video, we solved restaurant growth, which was 40th question in our SQL 50 series. And in this video, we are going to tackle friend request 2, who has the most friends. So let's dive in. Okay, so in this question, we are given request accepted table, which has three columns: request ID, acceptor ID, and accept date, where request ID and acceptor ID is the primary key combination of the columns with unique values for this table. Now, this table contains the ID of the user who sent the request, the ID of the user who received the request, and the date when the request was accepted. Now, we have to write a solution to find the people who are the most friends and the most friends number. The test cases are generated so that only one person has the most friends. The result format is in the following example. So in the example 1, we can see that 1 is a friend of 2 and 1 is friend of 3, 2 is friend of 3 and 3 is friend of 4. Also take a note that if 1 is a friend of 2, then 2 is also friend of 1. Similarly, 1 is friend of 2 and 3 is friend of 1. So this is bidirectional. So if you send a request to someone and someone accepted your request, which means you both are friends. It doesn't matter who sent the request to you. So let me explain you. So first let's see the output. So in this case, we can see that one has friend as 2, one has friend as 3. So one has two friends. 2 has friend of 3 and 2 has friend of 1. So 2 has total of 2 friends. 3 has friend of 4, 3 has friend of 2 and 3 has friend of 1. So 3 has total of 3 friends. So ID 3 has 3 friends. So this is the output. So you can see in the query, we have to find the people who has the most friends and the most friends number. So user with ID of 3 has 3 friends. Okay. And there is a follow-up question as well. In the real world, multiple people could have same most number of friends. Could you find all the people in this case? So in the given question, we have to find only the one person, and also given that the test cases are generated so that only one person has the most friends. So we obviously get only a single entry, but in the follow-up, we have to find all the entries where multiple peoples can have maximum friends. Okay, so first we will understand this question and then later we will do the follow-up question. Okay, so one thing you notice here is that if one is a friend of 2, then 2 is a friend of 1. Okay, so you will not find an entry in the table similar to this. Okay, so if there is an entry with 1 is a friend of 2, then there you will not find an entry where 2 is one friend of 1. And if you find 2 is a friend of 1 as an entry in the table, you will not find an entry where 1 is friend of 2, because it is obvious. It doesn't matter who sent the request to someone. If someone accepted your request, then you are the friend of the other person. So if 1 is a friend of 2, it's obvious that 2 is friend of 1. So in the given table, it is given that 1 sent the request and the acceptor is 2. Similarly, 1, 3, 2, 3 and 3, 4. So we can say that 1 is friend of 2 and 2 is also friend of 1. So what if I create a temporary table which looks like something? So 1 is friend of 2, okay, 2 is friend of 1. 1 is friend of 3, 3 is a friend of 1. 2 is friend of 3, 3 is friend of 2. And 3 is friend of 4, 4 is friend of 3. Now these are the two columns. But if you notice, these two columns are same. Okay, there is one in the first table, but there is one in the other table. There is 2 in the second table, there is 2 in the other table, because these are the reverse of the entries. 1 is friend of 2, 2 is friend of 1. So what if we take the first column or the second column? So this is the first column. So let's say this is the temporary table we created. Now in this we can count the number of people. So one has two friends. So one has 2 as friend, one has 3 as friend. So the total is 2 friends. 2 has a total of 2 friends. 2 has friend as 1, 2 has friend as 3. 3 has 3 friends. 3 has 1 as friend, 3 has 2 as friend, and 3 has 4 as friend. So in the end, what we have to return is the ID of the person and their number of friends. By using this temporary table, we can find that easily. So let us write the query to understand this better. So what we have to write is, first we'll select all the IDs as I have explained you. So first let's select that we'll store this in temporary table later. So select, what we have to select is requester ID as ID from request accepted. Okay. Then similarly, we will select acceptor ID from the same table, and then we join these two tables, that is union all. Now let's see the result of this query. Okay, so this is what we got. So 1 appear 2 times, 2 appear 2 times, 3 appear 3 times, and 4 appears single times. And I have explained you the logic behind like collecting all the requester ID and acceptor ID. If someone is accepting and someone is requesting, then these are the friend of each other. So one send the request to two, doesn't matter. What matter is this, one is a friend of two and two is friend of one. So we'll collect the requester ID and the acceptor ID, and they together will make that who has how many friends. Okay, so this table has all the IDs with all IDs as, we'll store this as all IDs. Okay, now what we have to do is we have to select the ID, their count. So we have to select, ID and count as number from all IDs. Now we have to group this table. So we have all the IDs here. We have to group by what? ID. Here we have to group by again ID, that is 333, then 2, then 4. Okay. So we have to group by ID and we have to select the count in each group. Now let's see the result of this query. Group by ID. Okay, so we can see in the output 1 has 2 friends, 2 has 2 friends, 3 has 3 friends, and 4 has 1 friend. We have to select this entry. And how will we select? We have to order by what? Order by num, okay, in descending order such that the maximum number comes at the top. So order by num, so that 3 will come at the topmost entry, and then we will select that topmost entry only. Okay, so test case has been passed. Now let me tell you something different. In the group by ID, we can write something like, since ID is the first column, we can write group by 1, order by num. Num is the second column, so we can write order by 2 and limit 1. So if we run the query again, we will see that our test case is still passed. Now we'll try to submit this and see if the solution can pass all the test case or not. Then we'll solve the follow-up question. So you see our solution got accepted. Now we will solve the query for the follow-up. Now this query will select only the topmost entry because it is mentioned in the question that there will only be a single person who will have the most number of friends. But the follow-up is saying, what if multiple people have maximum number of friends? How will you select all those peoples? Okay, so this query. So what we will do is we are limiting to 1. We won't limit this. What we will do is we will select this. So let's see what we will get. Okay, this is what we got. The topmost entry is at the top. Now from this table, you have to select all those entries where the num is equal to 3. Since there is no other like entry where the num is 3, let us create a test case. So this is just a duplicate of this. So what we will do is you can see in the output that 2 has 2 friends, but if we add something one entry more, we'll create 2 has 3 friends. So we'll create 2 has multiple friends. So let us copy this entry. Okay, and paste it. So 1 has 2 as a friend, and let's write 4 has 2 as a friend. Okay, now let's run the query again. So you can see in the resulting output that 2 has 3 friends, 3 has 3 friends. So what we have to do is we have to select these 2 entries. And how will you select? So first, this query, that is giving us this output, we'll store this as with friend count, that is friend count, okay, as this. Now what we have to select is we have to select the maximum number of friends. And what will give us maximum number? From this query, if we select the topmost entry, and from the topmost entry we will select the new, which will give us the maximum friend. So we'll select max friend as select from topmost entry, we'll select the new from friend count, okay, limit 1. So what will this give us? Max friend will give us the num, that is first entry, that is limit 1 in the friend count. So in the friend count, that is this is the friend count. In this we will select the topmost entry, that is limit 1, and then we will select the num. Now from the friend count, this is the final query, that is select something from friend count where what? Where the num is equal to what? Select num from max friends, okay, and what we have to select is we have to select the id comma num. Now let's see the result of our this long query. So max friend, we forgot to write comma here. Okay, so our second test case has been failed. Now let's see the reason behind that. This is our output and this is what we are expecting, okay. In case 2, 2 has 3 friends and 3 has 2 friends, but we have to get only 2 has 3 friends. Okay, so to solve the follow-up question, since case 2 is failing, the reason being that this test case are passed against the solution of this query. But we have to do what? We have to solve for the follow-up. So for the follow-up, the solution is correct. 2 has 3 friends and 3 has 2 friends. Okay, and it is failing. The reason being the same, that the solution is ran against the question, not the follow-up. So that's our solution. And I think there is no way to run the cases against the follow-up. But if we submit the solution, our all the test cases will be passed. You know why? Because it is mentioned in the question that the test case are generated so that only one person has most friends. And if the one person has most friends, this query will work. So let's see if this query works or not. So you can see that our query has been accepted.